Hi there. In this video, we will go over the AWS Certified Cloud Practitioner cheat sheet for Domain 3 technology. We will cover the exam curriculum for the AWS Certified Cloud Practitioner exam. We will cover these 4 topics. Define methods of deploying and operating in the AWS Cloud. Define the AWS global infrastructure. Identify the core AWS services. And identify resources for technology support. We will go into further detail for each of these topics. We will go into these separate subtopics. For 3.1, define methods of deploying and operating in the AWS Cloud. We will go over deployment services and deployment strategies. For 3.2, define the AWS global infrastructure. We will cover regions, availability zones, and edge locations. For 3.3, identify the core AWS services. We will cover the main AWS services, which are compute services, networking and content delivery, databases, storage, management tools. And finally, we will end up with identifying resources for technology support. We will go over the various support plans that AWS offers to its clients. First, designing a deployment solution for your application is a critical part of building a well-architected application on AWS. There are 2 aspects of deployment solutions: AWS deployment services and AWS deployment strategies. AWS deployment services provides several services that provide management capabilities for one or more aspects of your application lifecycle. Depending upon your desired balance of control, whether you want manual management of the resources versus convenience, which is AWS management of the resources, you can design your deployment service. When designing a deployment solution on AWS, you should consider how your solution would address the following capabilities. How do you provision? How does the deployment service help to provision cloud resources? Should you create the raw infrastructure, or should managed service infrastructure from AWS cover that for your application? Configure. How much customization does the deployment service permit? What is the level of customization your infrastructure needs based on environment, runtime, security, availability, performance, network, or other application requirements? Deploy. How much deployment automation does the deployment service permit? Do you need to install or update your application components onto infrastructure resources and manage the transition from a previous application version to a new application version? Scale. How does deployment service permit you to scale or descale cloud resources? How to proactively or reactively adjust the number of resources available to your application. Monitor. How does the deployment service permit you to monitor your cloud resources? How do you track resource usage, deployment success failure, application health, application logs, configuration drift, and more? These factors are important for your deployment solution. So now we will go over the various deployment services that are available to AWS customers. Over here, we will first go over AWS Cloud Formation and AWS Elastic Beanstalk based on the deployment service criteria. First of all, what is AWS Cloud Formation? Cloud Formation offers granular control over the provisioning and management of all application infrastructure components, from low-level components such as route tables or subnet configurations to high-level components such as CloudFront distributions. For the purpose of the AWS Cloud Practitioner exam, it will be just important for you to have an overall knowledge of these aspects, but you do not need to memorize them. With respect to provisioning, AWS Cloud Formation would automatically create and update infrastructure components that are defined in a template. With respect to configuration, AWS Cloud Formation templates offers extensive flexibility to customize and update all infrastructure components. With respect to deploy, AWS, you can update your CloudFormation templates to alter the resources in a stack. For scalability, CloudFormation will not automatically handle infrastructure scaling on your behalf. However, you can configure auto-scaling policies for your resources in a CloudFormation template. And finally, monitoring. CloudFormation provides native monitoring of the success or failure of updates to infrastructure defined in template, as well as drift detection, to monitor when resources defined in template do not meet specifications. Now we go over AWS Elastic Beanstalk. AWS Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications. Elastic Beanstalk will create all infrastructure components necessary to create a web application or service that runs on one of its supported platforms. If you need additional infrastructure, this will have to be created outside of Elastic Beanstalk. This covers the provisioning factor. Configuration on AWS Elastic Beanstalk. Elastic Beanstalk provides a wide range of options for customizing the resources in your environment. Deploy for Elastic Beanstalk. Elastic Beanstalk automatically handles application deployments and creates an environment that runs a new version of your application without impacting existing users. Scalability with Elastic Beanstalk. Elastic Beanstalk will automatically handle scaling of your infrastructure with managed auto-scaling groups for your application instances. Elastic Beanstalk offers built-in environment monitoring for applications including deployment success failures, environment health, resource performance, and application logs. This covers monitoring. Continuing on 3.1, defining methods of deploying and operating in the AWS Cloud, we now cover the two additional deployment services, AWS Code Deploy and Amazon Elastic Container Service. First, we will cover AWS Code Deploy. AWS Code Deploy is a fully managed deployment service that automates application deployments to compute services. How is provisioning taken care? Code Deploy is intended for use with existing compute resources and does not create resources on your behalf. Code Deploy requires compute resources to be organized into a construct called a deployment group in order to deploy application content. Configuration. Code Deploy uses an application specification file to define customizations for compute resources. Deploy. Depending on the type of compute resource that Code Deploy is used with, Code Deploy offers different strategies for deploying your application. Scalability. Code Deploy does not support scaling of your underlying application infrastructure. However, depending on your deployment configurations, it may create additional resources to support blue-green deployments. Finally, monitoring. Code Deploy offers monitoring of the success or failure of deployments, as well as a history of all deployments, but does not provide performance or application level metrics. Now going to Amazon Elastic Container Service. Amazon Elastic Container Service, ECS, is a fully managed container orchestration service that supports Docker containers and allows you to easily run applications on a managed cluster. Amazon ECS, how does it provision? Will provision new application container instances and compute resources based on scaling policies and Amazon ECS configurations. Amazon ECS supports customization of the compute resources created to run a containerized application, as well as the runtime conditions of the application containers. Deploy. Amazon ECS supports several deployment strategies for your containerized applications. Scale. Amazon ECS can be used with auto-scaling policies to automatically adjust the number of containers running in your Amazon ECS cluster. Finally, monitoring. Amazon ECS supports monitoring compute resources and application containers with CloudWatch. We continue with 3.1, defining methods of deploying and operating in the AWS Cloud, and we are going over AWS deployment services. We will now cover Amazon Elastic Kubernetes Service, which is also known as EKS. Amazon Elastic Kubernetes Service, EKS, is a fully managed, certified Kubernetes conformant service that simplifies the process of building, securing, operating, and maintaining Kubernetes clusters on AWS. How does it provision? Amazon EKS provisions certain resources to support containerized applications. For example, load balancers, compute resources, and application container instances. Configure. Amazon EKS supports customization of the compute resources, aka workers, if using EC2 instances to supply compute power. Deploy. Amazon EKS supports the same deployment strategies as Kubernetes. Scale. Amazon EKS allows you to scale workers with Kubernetes Cluster Autoscaler and pods with Kubernetes Horizontal Pod Autoscaler and Kubernetes Vertical Pod Autoscaler. Monitor. The Amazon EKS control plane logs provide audit and diagnostic information directly to CloudWatch logs. The Amazon EKS control plane also integrates with AWS CloudTrail to record actions taken in Amazon EKS. Now we go over AWS Opsworks. AWS Opsworks is a configuration management service that enables customers to construct, manage, and operate a wide variety of application architectures, from simple web applications to highly complex custom applications. How does it provision? Opsworks stacks can create and manage certain AWS services as part of your application using chef recipes. Configure. Opsworks stacks supports customization of other infrastructure in your environment through layer customization. Deploy. All Opsworks operating models support deployment and update of applications running on registered nodes. When you start an instance after the setup recipe is complete, AWS Opsworks stacks automatically runs the instance deploy recipes. However, when you add or modify an app, you must deploy it manually on any online instances. How does it scale? Opsworks stacks can handle automatically scaling instances in an environment based on changes in incoming traffic. Finally, monitor. Opsworks provides several features to monitor your application infrastructure and deployment success. We continue with 3.1 defined methods of deploying and operating the AWS Cloud. We have completed AWS deployment services, and now we are going over AWS deployment strategies. There are 4 AWS deployment strategies: pre-baking versus bootstrapping Amazon machine images, also known as AMIs, blue or green deployments, rolling deployments, and in-place deployments. First, we go over pre-baking versus bootstrapping. When should you use this deployment strategy? If your application relies heavily on customization or deploying applications onto Amazon EC2 instances, then you can optimize your deployments through bootstrapping and pre-baking practices. What is the deployment strategy details? Installing your application dependencies or customizations whenever an Amazon EC2 instance is launched is called bootstrapping an instance. Pre-baking is the process of embedding a significant portion of your application artifacts with an AMI so you can launch multiple identical instances from a single AMI. Which deployment service can be combined with this strategy? There's no specific service, so it can be used with all the deployment services. For blue-green deployments, using a blue or green deployment strategy increases application availability and reduces deployment risk by simplifying the rollback processes if a deployment fails. What is the deployment strategy details? A blue or green deployment is a deployment strategy in which you create 2 separate but identical environments. One environment green is running the previous application version, and one environment blue is running the new application version. You can use this deployment strategy for deployment services such as Elastic Beanstalk, Opsworks, CloudFormation, CodeDeploy, and Amazon ECS. Rolling deployments. A rolling deployment is a deployment strategy that slowly replaces previous versions of an application with new versions of application by completely replacing the infrastructure on which the application is running. When should you use this deployment strategy? Unlike blue or green deployment, in a rolling deployment, there is no environment isolation between the old and new application versions. This allows rolling deployments to complete more quickly but has more risks. You can use a rolling deployment strategy with deployment services such as Amazon Elastic Container Services, Elastic Beanstalk, and Opsworks. In-place deployment. An in-place deployment is a deployment strategy that updates the application version without replacing any infrastructure components. An in-place deployment strategy detail allows you to deploy your application without creating new infrastructure. This approach also minimizes infrastructure costs and management overhead associated with creating new resources. However, the availability of your application can be affected during these deployments. You can use the deployment strategy with most deployment services. We now cover 3.2, define the AWS global infrastructure. Over here on the left, you see some examples of what an AWS region is. And within the AWS region, we have availability zones. And within that, we have data centers. Let's understand the definitions of these terminologies. Regions. A region is a physical location around the world where AWS has a cluster of data centers. Availability zones. Each group of the above mentioned cluster of logical data centers is an availability zone. So as you can see over here, these icons which represent the data clusters represents the availability zones which are within a region. As mentioned, a region is a physical location around the world. You can see over here some examples of regions. US East North Virginia region, which has 6 availability zones. US East Ohio region, which has 3 availability zones, also known as AZs. And US East Oregon region, which has 4. Understanding more about regions, factors that influence region selection. Number 1 is security and compliance. If local regulations require data to be stored in a particular country, then it is best to select a region that serves that particular country. Number 2, proximity. To maintain low latency speeds, it is best to use a region located close to your customers. For example, if your application serves primarily Chinese users, then select China region. Number 3, feature availability. Certain AWS services are only available at select AWS regions. And for example, certain services are only available in the US regions or maybe Singapore or other countries, other regions. Number 4, pricing. Cost of AWS services can vary by region, so depending on where your users are based, you should select the right region to optimize for AWS cost against revenue from users. Finally, going over edge locations. What are edge locations? Edge locations are worldwide locations of places where data is cached to provide low latency services to users of AWS services. Edge locations are actually a part of CloudFront. What CloudFront does is it connects to the host, which is your EC2 server or S3. If data is not already cached in an edge location, then CloudFront makes a request to the origin if the data object is not cached. Once it's made the request and it stores the data for caching, CloudFront sends your distribution configuration, but not your content, to all its edge locations where CloudFront caches copies of your files. So this completes defining the AWS global infrastructure. We now go over 3.3, identifying the core AWS services. First category, instances and virtual machines. Within compute services, with respect to instance and virtual machines, we have 5 different services: Elastic Compute Cloud, also known as EC2, EC2 Spot, EC2 Autoscaling, Amazon Lightsail, and AWS Batch. Amazon EC2 is a web service that provides secure, resizable compute capacity in the cloud. And the service use case is to secure and provide resizable compute capacity in the cloud. What is Amazon EC2 Spot? EC2 Spot instances let you take advantage of unused EC2 capacity in the AWS cloud for up to a 90% discount compared to on-demand prices. The service use case is to run fault-tolerant workloads for up to 90% price off the on-demand prices. Amazon EC2 Autoscaling helps you maintain application availability and allows you to automatically add or remove EC2 instances. The service use case is to automatically add or remove compute capacity to meet changes in demand. Amazon Lightsail is an easy-to-use virtual private server that offers you everything needed to build an application or website, plus a cost-effective monthly plan. The service use case is easy-to-use cloud platform that offers you everything you need to build an application or website. AWS Batch. AWS Batch plans, schedules, and executes your batch computing workloads. The service use case is a fully managed batch processing at any scale. Within compute services, we now go over the category of containers. There are 2 services: Amazon Elastic Container Service and Amazon Elastic Kubernetes Service. Amazon Elastic Container Service, also known as ECS, is a fully managed container orchestration service. The service use case is to provide highly secure, reliable, and scalable way to run containers. Amazon Elastic Kubernetes Service. Amazon Elastic Kubernetes Service, which is EKS, gives you the flexibility to start, run, and scale Kubernetes applications in the AWS Cloud or on-premises. The service use case is to provide a fully managed Kubernetes service. Finally, within the category of serverless, we have AWS Lambda. With Lambda, you can run code for virtually any type of application or backend service, all with zero administration. The service use case is to run code without thinking about servers and to pay only for the compute time that you actually consume. We continue with 3.3, identifying the core AWS services, and now we go over networking and content delivery. In the category of building a cloud network, we have 2 networking content delivery services: Amazon VPC, also known as Virtual Private Cloud, and Amazon Route 53. Amazon Virtual Private Cloud is a service that lets you launch AWS resources in a logically isolated virtual network that you define. What is the use case? To define and provision a logically isolated network for your AWS resources. Amazon Route 53. Amazon Route 53 is a highly available and scalable cloud domain name service, DNS web service. The service use case is to route users to internet applications with a managed DNS service. Within the category of scaling your network, we have Elastic Load Balancing. ELB, or Elastic Load Balancing, distributes network traffic to improve the scalability of your applications. The service use case is to automatically distribute traffic across a pool of resources such as instances, containers, IP addresses, and Lambda functions. Within the category of building a hybrid IT network, we have AWS Virtual Private Network for the client. AWS Client Virtual Private Network, or VPN, is a fully managed remote access VPN solution used by your remote workforce to securely access resources within both AWS and your on-premises network. The service use case is to connect your users or to AWS or on-premises resources using a virtual private network. AWS Virtual Private Network VPN for site-to-site. AWS Site-to-Site VPN is a fully managed service that creates a secure connection between your data center or branch office and your AWS resources using IP security IPsec tunnels. The service use case is to create an encrypted connection between your network and your Amazon VPC or AWS Transit gateways. AWS Direct Connect. Using AWS Direct Connect, you establish a private connection between AWS and your data center to increase bandwidth throughput and provide a more consistent network experience through internet-based connections. The service use case is to establish a private, dedicated connection between AWS and your data center, office, or co-location environment. Finally, going over content delivery networks, which we covered previously, Amazon CloudFront. Amazon CloudFront is a fast content delivery network (CDN) service that securely delivers data, videos to customers globally with low latency and high transfer speeds. The service use case is to securely deliver data, videos, applications, and APIs to customers globally with low latency and high transfer speeds. Continuing with identifying the core AWS services, we now go over database. In terms of database type, we have 4 database types. For the purpose of the AWS Cloud Practitioner exams, we will only cover these 4 database types: relational database types, key value, document, and graph. The database services that cover database type for relational database are Amazon RDS and Amazon Aurora. Amazon RDS, or relational database services, makes it easy to set up, operate, and scale a relational database in the cloud with 6 familiar database engines to choose from, which include Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and SQL Server. The service use case is for traditional applications, ERP, CRM, and e-commerce. For the purpose of the AWS Cloud Practitioner exam, it is very critical that you remember the service use case with the database service that you are going to be using. Continuing with a relational database type and the database service Amazon Aurora. Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud that combines the performance and availability of traditional enterprise databases with the simplicity and cost effectiveness of open source databases. Again, the service use case is the same: traditional applications, ERP, CRM, and e-commerce. Going over key value database types, we have Amazon DynamoDB. Amazon DynamoDB is a key value and document database that delivers single-digit millisecond performance at any scale. The service use case is for high-traffic web apps, e-commerce systems, and gaming applications. For document database types, Amazon Document DB with MongoDB compatibility. Amazon Document DB is a fast, scalable, highly available, and fully managed document database service that makes it easy to store, query, and index JSON data. The service use case is for content management, catalogs, user profiles. Finally, we have for graph database types, we have Amazon Neptune as the database service. Amazon Neptune is a fast, reliable, fully managed graph database service that makes it easy to build and run applications that work with highly connected datasets. The service use case is for fraud detection, social networking, and recommendation engines. Continuing with identifying the core AWS services, we now go over storage. There are 5 storage types, which are object storage, file storage, block storage, edge computing and storage, and data transfer. We cover the first storage service, which is Amazon Simple Storage Service, which is S3. S3 is an object storage service that offers industry-leading scalability, data availability, security, and performance. The service use case is object storage is built to store and retrieve any amount of data from anywhere. File storage type. There are 2 storage services for file storage. First is Amazon Elastic File System, also known as EFS. Amazon EFS provides a simple, serverless, set and forget elastic file system that lets you share file data without provisioning or managing storage. The use case is scalable, elastic, cloud native, network file system, file system. Then we have Amazon FSx for Windows File Server. Amazon FSx for Windows File Server provides fully managed, highly reliable, and scalable file storage on Windows Server, delivering a wide range of administrative features such as user quotas, end user file restore, and Microsoft Active Directory integration. The service use case is fully managed file storage built on Windows Server. Block storage. Amazon Elastic Block Storage is a storage service used for block storage type. EBS or Elastic Block Storage is an easy-to-use, high-performance block storage service designed for use with the Amazon Elastic Compute Cloud EC2 for both throughput and transaction-intensive workloads at any scale. The service use case is easy to use, high-performance block storage at any scale. Then going over edge computing and storage types, we have AWS Snow Family. AWS Snow Family helps customers that need to run operations in austere non-data center environments and in locations where there's lack of consistent network connectivity. The service use case is to provide highly secure, portable devices to collect and process data at the edge and migrate data into and out of AWS. Finally, going over data transfer, we have two service types, AWS Storage Gateway and AWS Transfer Family. Customers use Storage Gateway to simplify storage management and reduce costs for key hybrid cloud storage use cases. The service use case is hybrid cloud storage service that gives you on-premises access to virtually unlimited cloud storage. Then we have AWS Transfer Family. AWS Transfer Family lets you preserve existing data exchange processes using file exchange over SFTP, FTPS, and FTP while taking advantage of the superior economics, data durability, and security of Amazon S3 or Elastic File System. The service use case is simple and seamless file transfer to Amazon S3 and Amazon EFS using existing data transfer methods such as SFTP, FTPS, and FTP. Continuing with identifying the core AWS services, we now go over the last part, which is management tools. There are three main management tool types that you should be aware of for the AWS Cloud Certified Cloud Practitioner exam: enterprise governance and control, provision and orchestration, monitoring, and observability. The management tool services that are available for enterprise governance and control are: first, AWS Control Tower. With AWS Control Tower, builders can provision new AWS accounts in a few clicks, while you have peace of mind knowing that your accounts conform to company-wide policies. The service use case is it is the easiest way to set up and govern a secure multi-account AWS environment. AWS Organizations. AWS Organizations helps you to quickly scale your environment by allowing you to programmatically create new AWS accounts. An AWS account is a container for your resources. The service use case for AWS Organizations is to centrally manage and govern your environment as you scale your AWS resources. AWS Budgets. AWS Budgets allows you to set custom budgets to track your cost and usage from the simplest to the most complex use case. The service use case of AWS Budgets is to improve planning and cost control with flexible budgeting and forecasting. AWS Well Architected Tool helps you to review the state of your workloads and compares them to the latest AWS architectural best practices. The service use case of AWS Well Architected Tool is to review your architecture and adopt best practices. Within provisioning and orchestration management tool type, we have AWS CloudFormation and Opsworks. CloudFormation template describes your desired resources and the dependencies so you can launch and configure them together as a stack. You can use a template to create, update, and delete an entire stack as a single unit as often as you need. The service use case of CloudFormation is to speed up cloud provisioning with infrastructure as code. AWS Opsworks is a configuration management service that provides managed instances of Chef and Puppet to automate how servers are configured, deployed, and managed across your EC2 instances or on-premises compute environments. The service use case of Opsworks is to automate operations with Chef and Puppet. For monitoring observability, we have Amazon CloudWatch and CloudTrail that you should be aware for AWS Certified Cloud Practitioner exam. AWS CloudWatch collects monitoring and operational data in the form of logs, metrics, and events, providing you with a unified view of AWS resources, applications, and services that run on AWS and on-premises servers. The service use case of CloudWatch is observability of your AWS resources and applications on AWS and on premises. Finally, AWS Cloud Trail. AWS Cloud Trail is a service that enables governance, compliance, and operational auditing and risk auditing of your AWS account. The service use case of CloudTrail is to track user activity and API usage. We go over now the last part of the cheat sheet for Domain 3 technology, topic 3.4, which is identifying resources for technology support. There are 4 basic AWS support plans that you should be aware of for the Certified Cloud Practitioner exam, which is Basic, Developer, Business, and Enterprise. For the purpose of the exam, you do not need to remember each and every category of the support plans, but you should know the description of the support plans. So basic support is included for all AWS customers. Okay. For developer, it is recommended if you're experimenting or testing in AWS. Business is recommended if you have production workloads in AWS. And enterprise support plan is recommended if you have business and or mission critical workloads in AWS. One of the most critical things to remember for enterprise support plan is that unlike other support plans, enterprise support plans provides you with technical account management, dedicated training, and dedicated account assistance. AWS also provides 7 core checks for the basic and developer support plans, but for business enterprise, you get the full set of checks. The rest of the aspects you can just briefly read through, but it is not critical that you remember them. The only critical parts that you should remember is that technical account management, training, and account assistance is a specific option in the enterprise plan, but it is not provided within business, developer, and basic. With this, we come to the end of the cheat sheet for Domain 3 technology. If you found this video useful, please subscribe and hit the like button for more content. We have already covered Domain 2 and Domain 4 previously, and now we will create the cheat sheet for the final domain, which is Domain 1 Cloud Concepts, and we will cover these subtopics within Cloud Concepts, which are define the AWS Cloud and its value proposition, identify aspects of AWS Cloud economics, and list the different cloud architecture design principles. In our YouTube channel, we provide specific exam questions with answers for the AWS Certified Cloud Practitioner, specific with latest content for 2021. So please do subscribe and hit the like button, and see you in the next video. Thank you.